Now we're going to be taking a look at second order differential equations. That will be equations of the form d squared y by dx squared is equal to f of x. Naturally, what we do is that we integrate both sides, giving us dy by dx is equal to the integral of f of x with respect to x, and we can always move on from there. But upon integrating f of x, we're going to end up with a constant, right? So whatever the integral of f of x is, there's going to be the constant of integration right there. But then what happens after that is, given that there's a dy by dx here, we have to integrate a second time, leaving us with y is equal to the integral of f of x with respect to x plus c. And we're going to be integrating, we're integrating this, and we're going to be having another constant of integration, which we may call d. So what this is telling us is that when we are finding the general solution of a second order differential equation, we're going to end up with two constants. Without loss of generality, these two constants would be c and d. So let's look at an example. D squared y by dx squared is equal to x cubed minus 6x plus 2. So what do? Integrate both sides, leaving us with dy by dx is equal to what? X to the 4 over 4 plus 3, or rather that should be a minus 3x squared plus 2x plus a. We're going to be saying that a is our constant of integration here, right? So that is our first derivative. But we haven't solved the differential equation because we have to find what y is equal to that would make this true. We have not found y. We have found the first derivative of y. So what do? We are going to integrate a second time. So we'll have that y would be equal to what? X to the 5 over 20 minus x cubed plus x squared. Then what? Integrating a gives us ax, and we're going to have what? Our constant of integration here, which we will be calling b. In other words, this is telling us that the function that we found the second derivative of, and its second derivative is equal to x cubed minus 6x plus 2, is this function right here. That function is a solution to the given differential equation. So now let's look on another example. This time we're going to be saying that d squared y by dx squared is equal to 4 sine squared x. So d squared y by dt squared is equal to 4 sine squared t. Now we are going to be having some boundaries, or we're going to be given some conditions. These conditions will help us to find the particular solution of our differential equation. So a while ago we just found the general solution. Now we're interested in finding a particular solution. So what do we have? We have that when t is equal to 0, what happens? Y is equal to 1 and dy by dx is equal to 2. So let's do our first integration. So that our first integration would suggest to us that dy by dt would be equal to what? How do we integrate sine squared t? Well, let me just write this. Sine squared t dt. Integrating sine squared t would mean that we are integrating 1 minus cos 2t over 2 with respect to t. So what do we get from there? Let's go on to the next page. We will have that dy by dt, as I'm sure you know how to integrate sine squared t, but let's finish this, would be equal to 2 times t minus sine 2t over 2 plus c. C is our constant of integration here. Now remember, let's go back and see. We have that when t is equal to 0, dy by dt, oh yeah, this should be a t, dy by dt should be equal to 2. So we're going to make that substitution here. And so we'll have what? dy by dt, which is equal to 2, would be equal to, we're going to be substituting t equals 0 in here, so that would be 2 times t is 0, sine of 0 is 0 over 2 plus c, which implies to us that what? C is equal to 2. So that means that dy by dt would be equal to what? 2 times t minus sine 2t all over 2 plus c, but c is 2. So yes, we have found our first derivative. So keep in mind, when you're trying to find a particular solution, we're going to be using the value of the independent variable t and dy by dt as the boundaries that we're going to be taking note of. We need to finish the solution to this differential equation now. So what do? We say, alright, since we know the value of dy by dt, let's find y. So y would be equal to the integral of what we got before, this expression right here. So let's do that. Let's expand this. 2t, that would be 2t minus sine 2t plus 2. And we're integrating with respect to t. So let's do this. Y would be equal to t squared minus, or rather plus, cos 2t all over 2 plus 2t plus, what are we going to call our constant of integration here? Let's call it b. So b is our constant of integration. Now what are the variables we have here? We have t and we have y. What are the conditions that we were given that are applicable here? We have that y is equal to 1 when t is equal to 0. Let's make our substitution. So 1 would be equal to 0 squared is 0 plus cos of 0 would be 1 plus 0 plus b. So what does that suggest? That suggests to us that our constant of integration b would be equal to a half. So then, looking at this, what would y be equal to? Y would be equal to t squared plus cos 2t over 2 plus 2t plus a half. That is the solution to our differential equation. Before we close, you must know this little cheat when it comes to differential equations, because your exam will be a multiple choice. So if you're having difficulty working out a differential equation, you don't need to really integrate twice and all of that, especially since you want to manage time as best as possible. So what do? If you're given a differential equation, d squared y by dx squared, or some dy by dx squared, they're equal to some function f of x or some function of y or whatever. All you need to do is to say, okay, if you're having difficulty working it out, just take the choices a, b, c, and d and see which one of them would work. So you're going to take whatever function they have in a, you differentiate it, whether once or twice, substitute it in the function, and see whether it fits or not. If it does fit, then you know definitely that is the solution to the differential equation. You just take that answer.